Section 6.1 was all about graphing quantitative data, but we already covered this in the preliminaries PowerPoint, so be sure to view that file again, specifically slides 10 through 15. Recall that we talked about summarizing the distribution of quantitative variables by discussing shape, center, and spread of the data. We prefer to use the mean and standard deviation as the measure of center and spread, though if the distribution is skewed or has outliers, we really should use the median and the IQR, because median and IQR are resistant or unaffected by skew and outliers. Be sure you know how to use the 1.5 IQR rule to determine outliers, as well as how to read a box plot. Recall notationally we use mu for the population mean and sigma for the population standard deviation. X bar represents a sample mean and S a sample standard deviation. The only change in Chapter 6 is that we've added a categorical variable as well. So we are considering a quantitative variable across multiple levels or across multiple groups. And so we now will stack our box plots, histogram, or dot plots to look at our data set. Let's move on to Section 6.2, a quantitative response, and specifically the simulation-based approach to comparing two means. You'll see a lot of similarities between this slideshow presentation and that for Chapter 5, because there are a lot of similarities between Chapter 6 and Chapter 5. The big difference is that now our response variable is quantitative. In Chapter 5, we dealt with two categorical variables. In Chapter 6, we'll see how things change and how they don't when working with one quantitative and one categorical variable. We will still be comparing groups, so the explanatory variable will still be categorical. The response variable, though, is now quantitative. Like with comparing a categorical response, we will summarize our data using the difference between the groups. Now, however, it is a difference in means instead of a difference in proportions. The subscripts still denote groups, but we'll use mu to represent a population mean of the response variable instead of pi for the population proportion. Similarly, x bar will represent the sample mean of the response variable. So our parameter of interest in this situation is mu1 minus mu2, and our observed sample statistic will be x bar 1 minus x bar 2. The null hypothesis will always be that the two groups or two means are the same. We could write that either as mu1 minus mu2 is equal to 0, or mu1 is equal to mu2. The alternative hypothesis will still depend on the research question. We could use either notation seen in the null, but changing the equal sign to a less than, greater than, or not equal to sign based on what we hope to prove. Again, it is extremely important to use informative subscripts or define what 1 and 2 represent. Saying mu1 is less than mu2 tells me nothing if I don't know what 1 and 2 are. For example, in the bicycling to work study, we could write mu1 minus mu2 is not equal to 0, where 1 represents the carbon and 2 represents steel, or, using informative subscripts, mu c is not equal to mu s. Or any hypothesis test, what do we assume? That the null is true, or the null hypothesis that group does not matter, just like we did before. So how did we simulate that group did not matter in Chapter 5? We wrote the response variable, success-fail, on cards, mixed them up, and dealt them into same size groups as before to create one sample, assuming the null. But now we don't have any successes or failures. What has changed, and how will that change the simulation? You may already have a good idea of how to do the simulation based on what was done in Chapter 5 and the change from Chapter 5 to Chapter 6. If you aren't sure, work through the exploration, which will walk you through the steps. Also view the wrap-up for these sections, which will have a nice animation to view.